Our topic for today's discussion is failure mode and effect analysis. FMEA is a systematic method of identifying and preventing system, product and process failures before they occur. Failure or any potential errors or defects within a process, design or part, especially ones that affect the system. FMEA is a design tool for assessing risk associated with the different ways, modes in which a part or a system can fail, identifies the effects of those failures and provides a structure for revising the design to mitigate risk where it is necessary. It tries to question the process. If this failure occurred, then what could happen? It provides a method for quantitative analysis of risk. Quantitative means explaining the risk using numbers. After FMEA, the initial design can be refined to get an improved design and so on to find the final refined design with rarely any modes of failures. It also provides details about the design team, who are all the people responsible for the design of the system, who are responsible for the refinement of the design, etc. FMEA document allows somebody later to come back and review the work and use it for future designs. Why do we do FMEA normally? Most of the Indian companies didn't use FMEA in the past. If you have noticed, product refinement happening innumerable times after product is introduced into the market. For example, the Bajaj Pulsar's petrol tank shape, exhaust silencer, front cowl, etc. and Tata Indica 1998 model have seen product refinements after these products were introduced into the market. So the design needs to be changed after product fails in the customer's hand, which is a costly affair. If FMEA has been done, cost of design refinement changes can be saved, which will lead to increased profits. Customers always expect a product of high quality, and using FMEA, product of high quality and very rare failures can be supplied to the customers. Durability of the product will increase, which in turn leads to extended warranty periods. Product development times can be reduced if all the requirements of the customers are put into the product and checked for errors in design stage itself. Safety and reliability of the products can be ascertained using FMEA. Different types of FMEA. Different types of FMEA analysis exist, such as system FMEA, design FMEA, process FMEA. System FMEA is the highest level of analysis of an entire system that is made up of various subsystems. The focus is on the functions and relationships that are unique to the systems as a whole. The system FMEA includes failure modes associated with interfaces and interactions in addition to considering single point failures. It is done during the conception stage by the R&D department. Design FMEA. Design FMEA is done during design stage to identify any potential failure modes and causes that can occur during the manufacturing or assembly process, which are the result of the design. At the end of the design FMEA, a prototype with rarely any failure modes is built. Process FMEA. Process FMEA is required for all new parts or processes, change parts or processes, and carryover parts or processes in new applications or environments. The process FMEA document should be initiated before or at the feasibility stage prior to tooling for production and take to account all manufacturing operations from individual components to assemblies. FMEA steps. First step, we are going to identify the modes of failures. For example, if you are looking at a car, the car won't stop. What may be the reasons? Brake lever stuck, or brake wire disconnected, or braking fluid inadequate, etc. That is the different ways in which the failure may happen. Identify the consequences and related systems for each mode of failure is the second step. Example, consequence may be if the car won't stop, it may cause an accident, cause you to speed when you have to stop the car. The third step is we are going to rate the severity of each effect. If the failure mode causes an accident, the severity is very high. We rate the severity on a scale of 1 to 10, meaning 1 is less severe and 10 is very highly severe. Then we identify the potential root causes for each failure mode. So we are going to check why the car won't stop, what causes the car not to stop. Maybe the user was not applying the brake on time, or the user was driving too fast, or the braking system won't work, or the worn out of tires, etc. There are a lot of different possible causes of failure modes. Then we are going to rate the probability of occurrence of each root cause. We rate occurrence probability on a scale of 1 to 10, where 1 means probability of occurrence of failure is very less and 10 means the probability of occurrence is very high. Next, we are going to identify process control indicators. If at all there is any problem with the braking system, do the car have any system for indicating that there is a problem with the braking system? Like how we have indicators for seat belts, door not closed properly, etc. Or by simply checking whether brake levers are stuck or is there any screeching sound during braking. Next, we are going to rate the detectability of the failure mode. Again, detectability is rated on a scale of 1 to 10. If the car has any brake failure indicator built into the system, we can detect brake failure early and easily, so we rate it 1. And if there are no such system designed to detect failures, there is no way of detecting such failure from happening, so we rate 10 for detectability. Very hard to detect. Next, we need to calculate the risk prioritization number, which is severity times occurrence times detection. RPN is equal to S into O into D. From this RPN, which ranges from 1 to 1000, we can identify which failure mode is very critical. If the failure mode RPN is very large, nearer to 1000, that failure mode is very critical and first priority is given to this failure mode to address the design deficiency. If the failure mode is not addressed initially, it is going to cause a huge damage or some undesirable conditions. Last step is the most important step in the process. We are going to use design to mitigate high risk or high critical failure and reassess to ensure goals have been achieved. So we are going to assign a team from the R&D to study about the failure of braking system, in this case, the root causes and what needs to be done to remove the failure mode from occurring. So all this happens during the design stage itself. Like this braking system, there are n number of components and parts in a car. So during the design stage, we use FMEA to identify whether the system designed in a particular way may fail. If so, how to stop the failure mode from happening. So we refine the design again and again by applying FMEA to design the best, safe, reliable product for the customers to use. And this is the structure of the FMEA document. Details about the minutest component of the product need to be filled up in the document. And this FMEA document is used for future references.